everyone, we are the Climate Change Group, and today we'll be presenting on climate change. I am Alan, and I will be talking about the history of the development of the idea of climate change as well as its association with human activity. So, before the 1930s, there was an idea of a stable climate, so most people did not do anything in regards to it. However, in the 1930s, the media called attention to warming temperatures, which got the attention of people such as Guy Stewart Callendar, who discovered that there was a 0.5 degrees Celsius increase in mean global temperatures. He also hypothesized that this was the result of rising carbon dioxide concentrations. However, climate experts were skeptical because to them temperature data constantly fluctuated. As time progressed, more evidence of a warming world surfaced. For example, Swedish scientist Hans Almond discovered strong warming in northern regions as well as other indicators of warming including receding glaciers. This caused people to start to doubt the idea of climate stability. However, from the 1960s to around 74, average temperatures started falling. Ideas to explain this phenomenon, such as the urban heat island, surfaced and caused scientists to be confused on how the climate will change in the future, if at all. Many experts eventually attributed this cooling to the Milankovitch cycles, which were calculations based on minor variations in the Earth's orbit that could affect the climate. However, two New Zealand scientists reported that the southern hemisphere continued to get warmer while the north was cooling. This only contributed further to experts' confusion, and as a result, they could not reach a consensus. Eventually, the government pressured experts to figure out what was going on. Two teams of scientists led by different organizations, one being NASA and the other being the British government, were able to sift through enough climate data to both come to the conclusion that the world was warming. These two research groups were then joined by the NOAA to release annual climate updates. They received significant media attention and also did seem to show a trend of increasing temperatures. While at last most climate experts finally agreed that there was a strong warming trend, skepticism still remained. For example, skeptics pointed out how measurements were made by satellites, which did not reflect surface temperatures. Nevertheless, more evidence for warming surfaced, such as increased upper layer ocean temperatures. As for the cause, many experts simply accepted that greenhouse gases were the main cause of global warming. However, critics pointed out other possibilities such as variations in sun radiation and volcanic eruptions. Unfortunately for these skeptics though, evidence suggesting that greenhouse gases were the main contributor exists, such as warmer temperatures at night. In the early 2000s, a group led by Michael Mann constructed a graph of estimated northern hemisphere temperatures. This graph was referred to as the hockey stick graph as a result of its shape. This led to global warming being seen as more of a fact by everyone. In the same time period, climate skeptic Richard Muller led a study of his own, and ironically enough, he came to the same conclusion that the world is warming. Even so, skepticism still persists. For example, many critics point out that Antarctica seemed barely affected. This, however, did not surprise most climate experts since the large amounts of ocean in the south delayed heat entry into the atmosphere. It was also in this time period that most climate experts finally agreed that climate change was mostly caused by human activity.
My name is Cody Thomas and I'll be talking about extreme weather. So what causes extreme weather? Extreme weather is caused by weather cycles such as El Nino and La Nina. It also happens by chance, and it also occurs from global warming, which is caused from CO2 emissions into the atmosphere. So extreme weather and its effect on 2010. So 2010 had the most extreme weather since 1816. 2010 was the hottest, wettest, driest, and coldest year in recorded history. And the global temperature was 0.62 degrees Celsius higher than the 20th century average, which is either 13.9 degrees Celsius or 15 degrees Celsius. It's a mixed opinion based on articles on the internet. And 2010 had the lowest ever volume of Arctic sea ice with a 60% decrease from 1979 to 2009 average. And the Amazon had its second 100-year drought in a 5-year span. And a 100-year drought it's a 1 in 100-year chance of happening, and there was 2 of those droughts in a 5-year span. So after both droughts, the Amazon released 5 billion tons of CO2. And just for a comparison, the US emitted 5.4 billion tons of CO2 from fossil fuel in 2009. So extreme weather and its effect on 2020. So 2020 had a lot of wildfires on the west coast of the United States. There was 11,000 bursts of lightning between August 15th and 19th in California. And by November 10th, 4.2 million acres burned in California. It was the hottest September on record, and the Northern Hemisphere had the hottest summer on record. 2020 was the most active Atlantic hurricane season on record, and the carbon footprint is at its highest point right now. 2020 is predicted to be the hottest year on record, 1.1 degrees Celsius hotter than the 20th century average. And 2020 is the 3rd driest June for US records, and it was the 7th consecutive year with a record-breaking September. And I have a little chart, a little table up here for comparison on how much land was burned. We see 47 New Jersey. New Jersey is the 47th state ranked by acres, and Connecticut is the 48th state ranked by acres. And we see the wildfires burned somewhere between those two states, burning a total of 0.173% of the United States. So 2010 versus 2020 and the future. 2010 was a record-breaking year for many variables in the climate, and 2020 is predicted to be the hottest year and most likely one of the driest. And 2020 to 2024 time period as a whole has a 24% chance of being 1.5 Celsius degrees higher average in the pre-industrial age, which is worse than ever before. And as the years go on, conditions are becoming worse, and it's extremely concerning to see consecutive years with record-breaking data on extreme weather.
Hi, my name is Henry, and I will be talking about how climate change affects ecosystems and wildlife. So, in summary, climate change disrupts balance between interdependent plant and animal species. It reduces biodiversity, which is important for ecosystem survival. It adversely affects Earth's water, energy, carbon, and other element cycles. It causes species migration. It causes ocean acidification, which leads to coral reef bleaching. It causes flooding of wetlands and more frequent wildfires, as seen in California and in Australia. On this picture slide at the top left, you could see the flooding of wetlands. At the top right is a graph of fish migration, which shows that fish are moving to colder areas of the globe. At the bottom left is a picture of the Australia wildfires, and at the bottom right is a timeline of coral reef bleaching. COVID-19 on the surface. So up front, we've seen improvement in water and air quality. For example, in Venice, Italy, we've seen waters in the canal clear. We've seen a return of aquatic life. In places like India, Italy, and China, we've seen an improvement in air quality. And these are both direct effects of the lockdown. On the left side, you could see the waters in the canal are clear, and on the right side, you could see an improvement in air quality in China and in Italy. COVID-19 under the surface. So there's a misconception that COVID-19 is giving climate change a break. However, that's not true. Many rural areas in the tropics are facing increased pressure from land grabbing, deforestation, illegal mining, and wildlife poaching. There are reports of increased deforestation in Asia, Africa, and Latin America. There are also reports of illegal mining and deforestation on indigenous territories, and areas that are economically dependent on tourism face reduced resources as tourism slows. And these are all effects of COVID-19 because places that were guarded before are now left unguarded, which leads to all the illegal activity that we now see. So, connection between COVID and ecosystems and wildlife. As global wildlife trade persists and human activities expand deeper into tropical forests, humans are increasing their exposure to wild animals and the diseases they may carry. When mining and logging degrade or destroy wildlife habitats, animals are forced into different or smaller areas and are more likely to become stressed or sick. They are also more likely to come into contact with people and domestic animals, driving the transmission of disease from wildlife to humans. We know that wildlife species threatened by exploitation or habitat loss are more likely to become sources of disease, and new research suggests that outbreaks of animal-borne illness will become more frequent due to the accelerating destruction of nature.
My name is Roberto, and I'm going to be talking about the natural side of climate change. We know that the greenhouse gas effect is a natural phenomenon where there are three major greenhouse gases, including water vapor, carbon dioxide, and methane. Water vapor is the most abundant greenhouse gas, which creates a feedback loop where any small increase in the temperature of the Earth causes water to evaporate, resulting in adding to the greenhouse gas effect and warming the Earth further, resulting in more water evaporating and repeating that cycle multiple times. When we look at carbon dioxide's main contributors, they include respiration and volcanic activity. Animals, of course, release CO2 from respiration. In the case of humans, we contribute millions of extra tons of carbon dioxide each year because we are so overpopulated. Volcanic activity also contributes to carbon dioxide levels. For example, the 1980 eruption of Mount St. Helens added 10 million tons of CO2 to the atmosphere in a span of 9 hours. Methane is another major greenhouse gas that comes through naturally through livestock and agriculture. Human involvement has resulted in 62% of total methane emissions coming from livestock, manure management, and agriculture such as rice production. We can see the proof of natural climate change falling into two very basic categories of records of the Earth's atmosphere and mass extinctions. Records of the Earth's atmosphere include geological records such as rocks, tree rings, ice sheets, and fossils of animals and coral reefs, all of which basically contain snapshots of carbon dioxide levels or oxygen levels, as well as the temperature levels and conditions during different time periods. For example, if you look at ice sheet cores, depending on how spread apart or close together the crystals in those sheets are, scientists can estimate the temperature of that region during a certain time period. Mass extinctions are another proof because they have a relationship with cooling or warming. For example, there was the global winter that famously came along with the mass extinction of the dinosaurs. There are two main causes of natural climate change. One of the main causes is mountain formations, newly exposed rocks absorbing carbon dioxide from the atmosphere, resulting in a decrease in the greenhouse gas effect, which resulted in cooling. An example would be when the North American Appalachian Mountains emerged, they absorbed CO2 from the atmosphere and led to a drastic cooling, and actually led to the world's first mass extinction because the oceans cooled so much that the water levels receded drastically and changed aquatic habitats. Volcanic activity would be the other main case of natural climate change through either the release of carbon dioxide and other greenhouse gases, which can cause warming, or the creation of a layer of ash and debris from the volcanic explosion that can cause cooling. For example, volcanic activity from the Siberian Traps released about 14.6 trillion tons of CO2 and resulted in the world warming by 25 to 34 degrees Fahrenheit. On the other hand, the Philippines Mount Pinatubo eruption caused the Earth to cool by 1/10 of a degree for several months. So, although volcanic activity does affect natural climate change, it has the ability to both contribute to global warming and global cooling.
Hello, I'm Salihi, and for this section of our presentation, I'm going to be looking at COVID-19's impact on climate change. And to start off, I have two graphs that are showing carbon dioxide emissions over two different sets of period of time. The one on the left being from 1970 to 2020 on a yearly basis, and the one on the right being January of 2020 to May 2020. Now, what's important to note from these two graphs is that how in the yearly graph we see from 1970 to now 2020 there has been a continuous increase in carbon dioxide emissions, CO2 emissions. Even though sometimes there's a slight decrease, it always picks itself back up. And it's important to look at that because there's always been an increase in a little bit of a decrease, but it hasn't been that much until 2020 when now we see a sharp decrease that's signified by the red, which is from January to May of 2020. And what's important to note from is that why is it this case? And most scientists can conclude, and I hope, and we as a group also conclude that it's from COVID and the fact that people have been in lockdown. More of a demonstration is that I have 6 graphs here. Top left being power, top middle being industry, top right being surface transportation, bottom left being public institutions, bottom middle being residential areas, and bottom right being aviation, or otherwise known as aerial transportation. And these are graphs showing carbon dioxide emissions over the past couple months from January to May of these various sections of humanity. As you can see, there's all of them have a decrease except for residential, and this further highlights the idea that COVID-19 is at least decreasing the carbon dioxide emissions because of the fact that people haven't been able to go to work as much and do these activities, which would then produce the carbon dioxide emissions into the air and increase it. It is important to note, though, that there's also showing an increase at the tail end of each of these graphs, which signifies the reopening of the world. There are two major negative effects of climate change. One is the fact that the Paris Climate Accord meeting had to have been postponed because the leaders of the various countries didn't want to get COVID. And this is important because this year would have been an event to see if the accord was reaching its benchmark and was being proved useful. And another, which is best summarized in this quote, COVID-19 and subsequent lockdown of economies have significantly brought down global carbon emissions. However, many argue that this would be a temporary phenomenon and emissions would rapidly rise once the lockdown restrictions are fully withdrawn. So I pose a question to you, our viewers. How should the U.S. economy change after the COVID-19 pandemic is over to better handle climate change, if at all? And what are some effects of climate change you personally have seen? Thank you very much for listening, and I hope you have a great day.